Hi, this is Roy with Mathmergency, and today we'll be working with plot and using the exclusions option to learn how to handle asymptotes in our graphs. So working with asymptotes in the plot function is not too bad, relatively simple. So let's give an example. Use the plot command, and remember the syntax for plot is the first thing you put in the braces is the function that you want to evaluate. Today we'll evaluate x squared plus x minus 6 over x minus 1. And you put a comma, and the next thing you put is the range of x values you want to evaluate. In this case, I want to evaluate from -2 to 2. Okay, and that's the basic graph of our function. And you can see, as we'd expect, there is an asymptote because asymptotes occur where the denominator equals 0, and in this case, if x is 1, the denominator is 0, and the function can't exist there. So we have this asymptote. Well, Mathematica draws it as it looks like a part of the graph. There are reasons why which are beyond the scope of this video, but if you're curious, you can look it up. It's not hard to find out why. In any case, there are a couple different ways to remove these asymptotes if you just want to see a clean graph. The first, and I don't know, the one that I honestly never use, is to put it in the iterator in here. And you need to know what value of x the asymptote lies on. So in this case, x equals 1 is where our asymptote is. So we need to put it in here between, or where it goes in order. So 1 falls between -2 and 2, so we're going to just put it in there like so. And when we hit enter, it's gone. So theoretically, you can exclude all the asymptotes you want by doing this. I find it's cumbersome, and you don't get quite the options that you need. There's no real control over this asymptote here. So the better way is an option called exclusions. Okay, and Mathematica has given us this exclusions to work with singularities and asymptotic data. As always, our options go after our first two required statements. It gets an arrow. So what can you do with exclusions? First, you can set it to a number. So if there's one asymptote like we have here, you can simply go ahead and put exclusions and type the number 1, and voila, it's gone. Okay, you see I've put here on the screen another plot command. And again, the syntax for reminder is first the function we're looking at, second the x values that we want to include. And you see this time there are two asymptotes as we'd expect from at x equals 2 and x equals 5. So again, I want to use the exclusions here. And I can simply put one number if I want. Let's choose 5. Okay. Or if I want, I could put a list of numbers to exclude. And remember, whenever you're putting a list of numbers in, you need to put them in curly braces. Separate them by commas. And there you have it. Exclusions 2, 5 will remove the asymptotes from x equals 2 and x equals 5. And this is a pretty clean graph. You see just a function value along the graph. We have another option which I think really exploits the power of this exclusions option, and that's we can set this. We can put an equation in here, and Mathematica will solve the equation and use that answer in our for our exclusions. So by way of example, we'll put in here, we want to exclude, let's say, x minus 2 equals, and when you put in an equation, always use a double equal bar, as you probably know. We want to know where x minus 2 equals 0. And so when we solve, we see it solved this equation, which obviously is x equals 2, and then excluded that. And our asymptote at x equals 5 stays. So this can be really handy for more complex graphs. So for instance, if you want to plot tangent x, let's say between 0 and 6 pi. So as you can see, there's a few asymptotes here, and you could go through and put in everyone in the iterator. You could also type exclusions and just manually make the list. But we can instead utilize the power of the exclusions option, and we're going to do that by putting ourselves an equation that tells us what asymptotes to exclude. And so tangent, as you know, is sine over cosine, and so we want to know where cosine x equals 0. And voila, this is a bare graph of our tangent function. Pretty exciting, huh? And we can make it look a little more familiar by making this, say, negative 6 pi. There we go. Okay, so for a tangent graph that kind of looks odd. I think we're used to seeing our asymptotes when we work with tangent, even when we work with regular polynomial, rational functions. And Mathematica gives us options to play around with our asymptotes. And so let me fix this here. So let's use our same tangent function. And let's add in our asymptotes. This time we want to maybe make them a lighter color so we can tell if there's something different. And Mathematica gives us an option called exclusions style. And exclusion style lets you do things with your exclusions, like make them look different, give them a different color. We're going to go into that real quick, but right now we just want to give them the color gray. And you can see that the function then has the purplish blue color and gray for our asymptotes, and that helps. We can take this one step further and make them dashed by adding the directives function. Sorry, directive. And it gets braces since it's an actual command. And within directive, you're allowed to put colors. You can specify a thickness by using thick or thickness, and then a number, and you can also put things like dash. And you can see now we have dashed asymptotes, and this is starting to look like a graph that we well know and love from learning our tangent functions. So the exclusion style is what you're going to use when you want to make your asymptotes look like in a particular way, fashion. Exclusions, though, is the power we've exploited today. We've excluded in our tangent graph everywhere that there is an asymptote for tangent. And you could do the same for the functions up here, simply copying the denominator and setting it equal to 0 in your exclusions. So I hope that helps. We'll be doing more videos shortly. If you have any requests, go ahead and send us an email or leave a comment. Thanks.